Assalamualaikum and good morning. My name is Mazin Jazmi and my teammates and I would like to present about our assignment. The topic that we choose is photoelectric sensors. Photoelectric sensors are sensors which are used to detect color and distance of an object. They are increasingly being used in industrial sector where they are used for detecting misalignments so that the information transmitted can make corrections. Before we know of its operation, let's know about its basic construction. The photoelectric sensor is constructed of a light source, light receiver, a main circuit, and an output circuit. The light source, which any light is acceptable. However, now in modern days, it is more efficient by using light emitting diodes or LED. The next one is light receiver. They receive the light emitted from the light source and converts it to an electrical signal. The next one is the main circuit, which operates the photoelectric sensors by supplying specified power to the components. The pulse oscillation circuit is used to produce pulse signal light. Last one is output circuit. Based on the signal it receives from main circuit, it outputs on and off signal.
Okay, next we move to the operation principle. There are several types of operation principle. First, properties of light, which is rectilinear propagation. When the light travels through air or water, it always travels in a straight line. So this is an example. Straight line. Okay, next, refraction. Refraction is a phenomenon of light being deflected as pass oblique through the boundary between two media with different refractive indices. Okey, ni sebagai contoh, sebagai satu contoh lah, kita ambil gelas isi air dan kita letak straw, kita boleh nampak perbezaan dia, perbezaan pada straw tu di mana luar dan dalam air. Okey, seterusnya reflection, regular reflection, retroreflection, diffuse reflection, which is a flat surface such as a glass or a mirror reflect light at an angle equal to the incident angle of the light. So this is an example. The light reflect on a mirror, regular mirror, retroreflection mirror, and diffuse reflection mirror. We can see the differences between this. Okay, next, polarization of light. Light can be represented as a wave that oscillates horizontal and vertical. So apabila ni adalah gambar diagram, bila cahaya menembusi filter, okey, di mana filter ada horizontal dan vertical, akan kita boleh lihat di mana horizontal cannot pass light while vertical pass light. Okay, next, light source, modulated light, which is a majority of photoelectric sensor use both modulated light that basically emit light repeatedly at phase interval. This diagram, light intensity versus time. We can see the cycle, while non-modulated light refer to an uninterrupted beam of light at specific intensity that used with certain type of sensor. We can see the flag. Okay, next, light source, color, and type. From the diagram, we can see light intensity versus wavelength, which is blue LED, green LED, red laser, red LED, infrared LED, di mana kita boleh lihat perbezaan adalah wavelength. Seterusnya, triangulation. Distance suitable sensor generally operate of the principle of triangulation, di mana emitted element, cahaya akan menembusi lens dan akan pantul pada objek. Objek itu akan pantul balik pada lens dan akan keluarkan image pada A dan B.
Hi there, I'm Urmila Aparao, metric number B0819104117, here to present the parameter equation for characteristic curves. Starting up with the excess gain, the ratio of receiving the light energy level to the threshold level while setting the sensitivity potentiometer maximum. This number means margin how much the sensor can be adjusted when the sensor is contaminated or condition of surrounding gets worse. For the interference area, how long distance the sensor will get crosstalk with other sensors mounted parallel of it. The sensor must be mounted taking the distance not get crosstalk. For the sensing area, it is the how wide the area of the sensor through the beam type can work horizontally while setting the sensitivity potentiometer maximum. This shows the horizontal margin of installing position. When it's small, the installing must be accurate. For the angular deviation, the tolerance of the angle of emitter or receiver that allows the sensor to work correctly. The sensor head must be mounted so that the angle is in this angle range. Another sensing area, it is how wide the area of the sensor diffuse reflective type can work horizontally while setting the sensitivity potentiometer maximum. This shows the horizontal margin of installing position. When it's small, the installing must be accurate. For the hysteresis, the minimum difference of distance that the reflective type of sensor can detect. The reflection ratio and the color of the objects influence this factor. For the spot size, the size of the emitted light spot of the sensor. The smaller the spot size, the smaller the object sensor can detect. The bigger the spot size, the wider the sensor can detect the object. For the material response, it is how much the BGS sensor get influenced from the material of the objects. The reference distance is for the white paper. For the color response, it is how much the BGS sensor get influenced from the color of the objects. The reference distance is for the white color. LED for emitter and photodiode for receiver. The most important device construct photoelectric sensors are LED for emitter and photodiode for receiver. Laser sensor has laser diode for emitter. The color of the light varies depends on its wavelength. Visible light is around 400 nanometer to 700 nanometer. Most of the photoelectric sensors have LED with visible light source. That's all from me. Thank you.
Assalamualaikum. My name is Muhammad Sharul. So, I will be explaining about the calculation of response of this sensor, the retroactive type. So, the time the sensor can use for detecting mark is response time is equal to the width. This is the width of the object. Alright, this is the width of the object and the line of speed. Here are the line of speed as given. So, to calculate it, you must know the width of the object. You divided by the line of speed. Here are given the line of speed already. So, as you can see, this is the conveyor. Okay, this is the conveyor. So, the line of speed of the conveyor is 5 meter per second. So you divided by the width of the object and the line of speed. So you get 1 millisecond. For this type of sensor working, you must meet the requirement of the sensor, that is 1 millisecond or smaller. Alright, for the response time. So on the next slide, we have on the next slide, this slide, I want to explain there are many type of reflective sensor, but it have a different sensing range. As you can see here, right? There are different sensing range and there are different sensing width of the object. Okay. Also, if the conveyor of the machine is faster, so there is a repeatability. Okay, different, also different here. Okay, there are different one also. Okay, here are the object. For instance, there are car here or an object. Okay, it will travel to milli per second. So we have to use this one, right? I hope you understand. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Aliza binti Azam. I will explain about the application of photoelectric sensor. Photoelectric sensor come in different housing style, type and size and can be adapted to industry need. This technology is used in many applications in industry and automation and has the speed, accuracy and reliability. There are three types of photoelectric sensor in common use. First, diffuse. A light beam is transmitted in the direction of the object in question. The light is reflected from the object which is received by the receiver of the sensor, confirming the presence of the object. The amount of light received is used by the sensor to measure the distance of the object. Second, retroreflective. A light is sent toward a reflector and the sensor detects the reflected light. An object being detected may block the transmitted or reflected light. Third, true beam. A light beam is transmitted from the transmitter on the receiver while the object of the interest is placed between the two. The object interrupts the changes of the amount of light that fall onto the receiver. This is used for sensing the object. Application of photoelectric sensor. First, automotive industry. Construction of a car body. Each part need to be transported down the line with precision. Each part need to slow down and stop in front of the relevant station with a perfect timing to ensure it can be welded or otherwise processed without any error. R201 retroreflective sensor with polarization filter can be used to regulate skid speed in this application, ensuring the skid will slow and stop when sensor beam is blocked by said skid. This application is suitable in many industrial processes as glossy material and material which a reflective surface does not affected by this sensor. Second, material handling. Automated storage technology using optical data coupler with wireless data transfer. Easier to store and transfer goods in warehouse. This application provides reliability, efficiency, and a wireless way to track and communicate with objects in transit inside warehouse storage facilities. Third, machine engineering. Ensure reliable and safe operation in theme park. Retroreflective sensor with a polarization filter detect the position of a carrier to be set on and off the track of a roller coaster. It helps to make placement and a removal of machine component efficiency without mistake. Food and beverage. Photoelectric sensor also used in manufacturing and packaging line in the food and beverage industry. Bottle cap feeding machine must correct aligning and orienting each bottle cap in the correct position of bottling. R201 series diffuse mode sensor can detect error. Even the smallest feed error register and incident are stopped before a capping mistake occur. This allows system a smooth running and provide accuracy that saves time and money. Fifth, door, gates and elevator. Automatic door and gates such as on buses, train, elevator and garage need to have reliable sensing technology. It can open and close at the correct time. The sensor need to see the entire area of the doorways for the automated door to work properly to allow people in and out of the bus. Using photoelectric sensor coupled with ProScan active infrared scanner, scan the entire step and door area where it can detect approaching people or vehicles. Thank you.